Welcome to the webinar on lifecycle assessment in the battery raw material value chain, LCA as a key driver for regulatory compliance and more sustainable practices. My name is Camilla. I'm the Marketing and Comms Manager at RCS Global, and I'll be moderating the webinar today. Before I introduce our excellent speakers, I would like to cover just a few housekeeping topics. Today's webinar is being recorded. We'll share a link with you after the webinar is complete. We welcome you to revisit any content yourself and share it with colleagues as well if they're not able to join. We also invite your comments and questions throughout the webinar. Please look at the bottom of your screen. You'll find a Q&A chat box. If you think of questions for our speakers at any point, just type them in there and we'll try to address them at the end of the session during the Q&A. Today's webinar is being presented by RCS Global in collaboration with Minviro and Euro Manganese. Our webinar will consist of 3 presentations and a Q&A session. We will start by welcoming Megan Leahy-Wright, Head of Strategy and Operations at RCS Global. Megan will be talking about the implications of increasing regulatory requirements for the battery raw material value chain. The second part, we hand over to Dr. Robert Pell, founder and CEO at Minviro, to talk about quantifying the environmental impacts of battery raw materials through LCA. And then we welcome Louise Burgess, Senior Director of Investor Relations and Communications at Euro Manganese. Louise will present a case study of Euro Manganese project of applying LCA in practice and experiences, results, and lessons learned. And without further ado, I'll hand over to Megan to kick off the session.
Great, thank you, Camilla. So hello, everyone, welcome. As Camilla just mentioned, my name is Megan Leahy-Wright. I'm Head of Strategy and Operations in our consulting unit at RCS Global. RCS Global is a leading vertically integrated ESG audit, consulting, and data solutions provider with a specialization in battery material supply chains. We have over 16 years of experience in responsible sourcing, and we work every day with major companies in the automotive, electronics, manufacturing, processing, trading, and mining industries to generate essential data and insights and to deliver practical solutions that enable our partners to make informed decisions about their ESG due diligence programs. Next slide, thanks. So I'm here today to speak about how the expanding landscape of due diligence regulation is impacting companies in the battery raw material value chain. So to kick that conversation off, I'll very briefly review a global issue that has led us all here today. Many of us will have seen this chart on the right in one form or another over the past few years. So this table here shows the increase in the volume of critical minerals required to produce the clean energy technology that we, as a society, have determined will enable us to meet global climate goals. The bar on the far left shows the total volume of critical minerals that was required to produce global clean technology in 2020, while the bar on the right of that, so the second from the left, shows that under current global policies for climate change, we will need an estimated twice as many minerals in 2040 as we did in 2020. Under more ambitious efforts to meet the Paris Agreement targets, we would need 4 times as many minerals by 2040, as seen in the third bar. And to achieve net zero globally by 2050, we would need 6 times as many minerals by 2040. As you see here, this darker green portion of the bars, it represents the minerals specifically required to produce EVs and battery storage to meet climate goals. So the message is clear that our climate goals require more minerals than are currently available in the market. In response to this challenge, as well as recent geopolitical issues impacting the availability of minerals in certain regions, many regulators have responded by developing broad strategies that aim to facilitate additional mineral extraction and processing, as well as manufacturing in the short term, while also consciously shifting towards circularity to reduce the need for additional mineral extraction in the long term. In fact, just today, the European Commission released its final draft of the EU Critical Raw Materials Act, which outlines many of these activities. To ensure that the additional mineral extraction, processing, and manufacturing that is required to achieve these goals doesn't end up causing more harm than good, governments have established a variety of regulation that requires companies to disclose information about the sources of their material, the conditions under which they were extracted, processed, or manufactured, as well as the environmental and social impacts. Over the past few years, a number of new regulations have emerged, particularly from within the EU and the US, that aim to enhance corporate responsibility for due diligence in mineral supply chains. So I won't have time to dive into the details of all these regulations. This list is also non-exhaustive, but what it shows is that the expectations on companies are increasing rapidly and covering more companies, geographies, and ESG issues. All of these regulations require companies to take concrete and measurable actions to address a wide range of ESG risks. And aside from those specifically targeting conflict minerals, they all impact actors throughout the battery value chain, either directly or indirectly. So what are the regulatory expectations for companies in the battery raw material value chain? Well, across the regulation, 3 key themes reappear. The first is that the regulation requires companies to establish and implement due diligence policies and procedures to identify, assess, and manage risks in the company's supply chain. This includes gaining transparency over the actors and the materials in your supply chain, collecting information on their performance, and assessing and mitigating actual or potential adverse risks. Another key theme, which is at the core of today's webinar, regulation is demanding more extensive disclosure requirements on the environmental and social impacts of a product during its entire life cycle. So the regulation increasingly demands that companies apply standardized approaches to calculate and measure potential impacts of a product. And this is achieved, for example, through applying a life cycle assessment methodology, which Rob will explain in greater detail shortly. A well-known example of this requirement in regulation comes from the EU battery regulation, which requires battery manufacturers to produce a carbon footprint declaration that accompanies each battery model and batch placed on the EU market. So following entry into force of the regulation, the European Commission will establish a common methodology to calculate the carbon footprint that must be applied for the life cycle assessment on carbon emissions throughout the value chain. And finally, in order to reduce waste and minimize the need for additional mineral extraction, regulation in the EU and US have established mechanisms that require companies to increase over time the proportion of recycled content in their batteries and to provide verification that the material was recycled. So what do these expectations require companies to do on a practical level? Well, life cycle assessments are indeed an essential tool for environmental and social risk management, but meeting the emerging regulatory expectations requires a much broader effort by companies, as demonstrated in this slide. So when we work with companies, we guide them through a step-by-step process that enables them to establish a holistic approach to due diligence, aligned to the company objectives, key regulation, and international good practice frameworks. These are, for example, the UN Guiding Principles or the OECD Due Diligence Guidance for supply chains of minerals from conflict-affected and high-risk areas. The first step that companies should take is to set a company strategy for due diligence, including setting targets and priorities for your own operations, as well as for your suppliers. And the next step, companies need to establish a due diligence management system. This includes a public commitment to due diligence and structuring internal procedures and resources in order to effectively implement the due diligence program. Companies then need to establish a chain of custody. This requires engaging with your suppliers to gain transparency over the supply chain and verify material provenance. This includes whether the material was mined or recycled. And next, companies need to collect data on the suppliers and their own operations in order to identify hotspots or high risks and determine appropriate mitigation measures. This is where LCAs play a major role, as they provide the essential data that enables companies to assess and locate specifically where the risks are highest and then make informed decisions about next steps. And finally, companies are required to disclose results to a range of stakeholders and publish an annual report on their due diligence systems and activities. They will also be required to disclose data electronically via battery passport. So how do companies benefit from following this step-by-step procedure? Well, you can benefit in a number of ways. With a due diligence management system and more precise verified data on supply chain risks through lifecycle assessments, your company can effectively manage ESG risks, ultimately enabling you to prevent or mitigate harm on people on the planet. Collecting data in a standardized way will contribute to industry efforts to measure global progress and to adapt approaches to meet climate goals. Following these steps will also ensure that your company complies with due diligence regulation globally and aligns with international good practice. It will help you establish a system that enables you to collect and verify the information that you need in order to demonstrate eligibility for tax credits, for example, through the US Inflation Reduction Act mechanism, or to become a premium supplier for customers that aim to drive down the total carbon emission in their supply chains. On the flip side, your company will be able to collect data from supplier that enables you to make more informed procurement decisions. For example, you can set requirements or incentives for suppliers that meet certain targets for carbon emissions or recycled content. And lastly, it will enable you to make informed decisions about where to invest in innovation or risk management, for example, to reduce carbon footprint in own operations and in your supply chain. So without further ado, I'd like to hand over now to Rob and Louise, who will dive into greater detail on the LCA methodology and an application within the battery raw material value chain.
That's great. Thanks very much, Megan. Hello everyone. My name is Robert Pell. I'm the founder and CEO of Minviro. I hope you can see my presentation screen. But I'm going to be talking a bit of a deep dive into the world of life cycle assessment and specifically quantifying environmental impacts of the battery raw materials value chain through life cycle assessment. So really just repeating what Megan mentioned earlier about we're living in the precipice of a real transition, a transition which is going to require raw materials in unprecedented amounts. And this means that we need to really have a focus on making sure that these raw materials are produced, whether that's coming from primary raw materials or through recycled routes, to make sure that they're produced with the lowest impact possible. And what we always say at Minviro is this low carbon, the sustainability of this low carbon transition is really going to be, the success of it is going to be dependent on how low the impact of the raw materials feeding it are. So a little bit of a background to Minviro before I get onto the technical LCA stuff. So Minviro is a pretty new company. We were formed in 2019 as a spin out from University of Exeter, Camborne School of Mines here in the UK. We've got a team, we're pretty rapidly growing, although we're pretty new. We've got a team of 27 in our London office. And we've completed close to 200 projects, LCA projects across the raw materials value chain. So a lot of our work has been with battery manufacturers, going right down to the mining and metals companies producing these raw materials feeding batteries, and going right through the value chain to recycling these batteries as well. But there's always different types of companies in this ecosystem that all need this information, whether it's due diligence information or life cycle assessment information. But I think what the really interesting opportunity that we had with Euro Manganese and with many other companies at the moment is a lot of these projects are in the design phase. So we work with developers, but also operators. But what's so enjoyable about working with developers is, their processing route, the design is not set in stone. You can apply life cycle assessment to measure impact and make informed decisions about how you can reduce that impact before the concrete is set and the project goes live. So you can really make a substantial impact by embedding life cycle assessment into that design phase. And although we do life cycle assessment, it is really a jumping off point to be able to do a lot of other value added bits of work. So we're a consultancy company and a technology company, and the technology that we provide, MineLCA, really is a tool that allows those in these companies to carry out life cycle assessment themselves, understand what the impacts of different decisions are at a project level for a product. For example, what's the impact reduction potential of having an electrified fleet at a mining site, or changing a processing route from one way to another. You can also do some other points like impact reduction, eco-design, material flow analysis, and circular economy modeling. But we'll focus on life cycle assessment today because of the limited time. And again, just to highlight these range of customers that we have across this value chain, so right down to the users of these essential materials like Tesla, but also operators like Pilbara, Livent, and also these developing companies like Euro Manganese here and some others as well. And just to highlight, I didn't want to steal Euro Manganese's thunder, so I thought I'd give some examples of some other LCA outputs that we've had for some of our clients that's publicly available. So this is what, for example, Livent used the LCA work that we did with them for their lithium hydroxide and lithium carbonate product. And I think what's really important to note is every single production route of these battery material products has a different embodied impact. And this is going to be due to a number of factors. You might have the geology, the mineralogy might dictate that you have to go through certain processing routes. But equally, you might have different infrastructure for the electricity that's providing the energy to do the processing at the processing site. So what you can see here at Livent, they've got lithium hydroxide coming through different processing routes, and they have quite different impacts. And so having this high resolution data for these supply chains going into batteries is really important. And you can see that that's been identified in the regulations that Megan mentioned earlier. Here's also an example from a different use case, so some work we did with Tesla in their impact report. And this is really highlighting the environmental or the climate change hotspots across their nickel-based cells using a life cycle assessment approach. So this is really powerful for them to understand where their risks are from a climate change perspective in their battery products. And you can see that nickel is a pretty big hotspot there. Graphite, as well as the cell assembly. But we've talked a lot about life cycle assessment, but how is it done? What is it? It's an approach which has been established for some decades to quantify the environmental impacts of products or processes. And you're maybe familiar with some of the impact categories like climate change, but it has a whole array of them. And in essence, what we're doing when we're conducting a life cycle assessment is we're collating all the data for the material and energy inputs going into a process or a project. This might be things like fuel, energy, water, chemicals, consumables. And we're also collating all the emissions that are going into the environment. So this can be atmospheric emissions, waterborne emissions, or solid wastes. We're then converting that data into those environmental impacts that I mentioned earlier and referencing it against a product. So, you may be looking at what's the impact, the climate change impact of producing 1 kilogram of manganese or 1 kilogram of nickel or lithium. Now, I mentioned the range of impact categories because there is some call it a carbon tunnel vision. We obviously have a common goal of trying to really mitigate these climate change impacts, and rightly so. We're in a pretty tough spot in terms of what we're trying to achieve in terms of climate impact reduction. But it's really important that we don't do this climate change impact mitigation at all costs. We really have to consider the consequences across a range of impact categories. For example, if we're minimizing climate change, do we have impacts on land use, on water availability, on maybe, it could even be things like toxicity. So it's really important to understand the trade-offs of different decisions that you have at a project. And that's what life cycle assessment allows you to do. This is just again highlighting that it's really important to understand the specific impacts of the materials and exactly where they're coming from, their production routes. This is a white paper that's available on our website. It's just called Shifting the Lens, and it's basically just comparing different raw material supply chains and seeing what it means in terms of the impact when you get down to the battery level. And so you can just see that the difference, the delta between low impact and high impact battery raw materials, keeping everything else equal, can have a quite a significant effect. And I encourage people to go and look at that paper if they want to really sort of have a deep dive in terms of the range of impacts based on different sources of manganese, of nickel, of cobalt. Yeah, it's really quite an interesting topic. So I mentioned our technology tools. I won't talk too much about this, but this one really allows companies in the mining and metals value chain to be able to carry out life cycle assessments quickly and easily internally, generate real insights on what the impact of their products are, but also really quick insights in how to navigate impact reduction for their projects. So, what options do they have for reagents, for consumables, for alternative electricity sources, and see what impact reduction potential that would have across a range of impact categories. And I'll just briefly talk about, as the title mentioned, it's really about understanding what the impact is when you get to a battery level. We also have a tool called MineBit, which allows companies to really understand the different supply chains of these raw materials, whether they're getting their lithium from South American brines versus Australian spodumene converted in China. Do that for your whole value chain based on Minviro's internal life cycle assessment data set for these materials, and then understand what that means at a battery level, at a cell level or a pack level. I'll just zoom through these. You can see some of the visuals that you might be able to get, make everything super specific and regional. Yeah, and that's the final slide. So I'm just really excited that the opportunity that we worked with Euro Manganese and help them understand where their impacts are and help them understand where their future goals are for their manganese product. Thank you.
Perfect. Thank you so much. Well, thank you to Megan and Robert for setting such a great scene here for, I think, where we're at. It's very, very exciting times in the battery raw material space. So just a big hello to everyone. It's good morning for me here in Vancouver, and good afternoon to those who are joining from the UK and Europe. As mentioned before, I'm Louise Burgess, the Senior Director of Investor Relations and Corporate Communications for Euro Manganese. I've been with the company for about a year and have responsibility for our external relations, including our sustainability program. I am honored to be part of this panel today and to share our experience as a raw material supplier in terms of undertaking 2 separate life cycle assessments. And as you can see, I've got a couple slides here. So if we can go to the next one, please. I'm not going to speak to the legal disclaimer, but I have to show it. So we will move on to slide 3, a little bit about who we are. I thought I'd also start there before going into kind of why we undertook those life cycle assessments for our project. So Euro Manganese, who are we? We are a Canadian-based battery metals company poised to become a leading producer of high purity manganese for the EV industry. Manganese is a small but very essential component in most EV batteries. So if you know much or anything about kind of chemistries, the NMC chemistry, which is about half of all lithium-ion battery chemistries. In that NMC, the M stands for manganese. And as you heard from Megan just today, hot off the press, We understand that manganese has been included as a strategic raw material under Europe's just released Critical Raw Materials Act, which is very exciting for us. Our flagship project is located in the Czech Republic, about 90 kilometers east of Prague. Chvaletice is the only manganese resource in Europe, which strategically positions us to deliver fully traceable, responsibly produced products to customers in the battery supply chain. Next slide, please. Chvaletice is quite a unique project in the sense that it is a waste to value project that involves reprocessing historical mine tailings through a proposed chemical plant to produce 2 high purity manganese products, manganese metal, or HPEMM, which is the flake, and the manganese sulfate, or HPMSM, which is the powder form. The schematic on the right of this slide shows the 3 tailings areas, which are currently large raised fields. That's what they look like. And the proposed processing facility down in the kind of bottom right here. And locating the plant adjacent to the resource means that we have no long distance or transportation, which in turn reduces our carbon footprint. And in reprocessing the old tailings, we are actually cleaning up a historic source of soil and water pollution in the area. The current tailings area is unlined and is leaching metals into the groundwater on a daily basis. So, I mean, I think Robert talked a little bit about the benefit of doing an LCA and then the ability to design the project in a manner that reduces environmental impacts and footprint. And that's really what we've aimed to do here with our project. So we've designed it using best-in-class environmental and safety standards. And some of the things that we plan to do there is use industrial wastewater from a neighboring power plant for process makeup water, so we're not drawing from local sources. We're looking to recycle our carbon and hydrogen process emissions and our reagents where possible. And we are also planning to use 100% renewable power for the processing plant. And we already have an MOU in place with Statkraft to supply green electricity to the project. We do not use selenium or fluorine in our process, unlike other high purity manganese producers. So that, I think, gives you a little bit of a basis and a picture of how important it is to us that we produce a low impact, a low carbon product. And while that's simply the right way to operate, you've heard from Megan that European regulation, particularly with the pending battery passport, will require batteries sold in the European Union from 2026 to report their overall carbon footprint. So how do we then kind of prove the environmental credentials of our products, and how do our products stack up against our peers is the question that we asked ourselves. And that was really the driving force behind why we partnered with Minviro and RCS Global to undertake these two LCAs last year. So the first LCA that we did was a cradle-to-gate critically reviewed study that quantified the environmental impacts of producing HPEMM and HPMSM at Chvaletice. And results of that confirmed a net positive benefit to water and soil quality over the course of the project, specifically as a result of the remediation of the historic tailings area. So Robert earlier mentioned a number of different environmental metrics that you could measure. And we did do that as part of that first LCA. Equally as part of that, we also measured the global warming potential, or GHG emissions, of the project. And as you can see on this slide here, by using that 100% renewable power versus the standard Czech grid, the carbon footprint of the project was reduced by half. So here in the graph, you'll see that like the middle light blue bars show the Czech grid mix versus the right green bars that show the renewable mix. Now, that first LCA actually also identified opportunities for us to further reduce the project's carbon footprint by sourcing reagents from manufacturers with lower environmental impacts than those currently assumed in the study. So in the spirit of what gets measured gets managed, we're already looking at ways we can engage with our reagent suppliers in the future to further reduce our Scope 3 emissions. I think this is pretty, it's pretty unprecedented in the sense that we're not even yet operating, and these are already some of the questions that we've asked ourselves and that we're looking at to further reduce those impacts so that by the time we are in operation, we're already in a fantastic position. Now, the second LCA was actually a benchmarking study that leveraged the work done in the first LCA around our carbon footprint. And then that compared our carbon footprint to the current incumbent industry. And again, that's kind of what you see on this graph here. So the far left bar, the dark blue, is the current incumbent industry versus ourselves being the two other bars there. And what you can see is that our products are currently 1/3 of the carbon footprint of the current industry. I think I will just caveat that for reference, more than 95% of the world's high purity manganese is currently processed in China. There's very, very little processing capacity for this critical battery raw material elsewhere. And in Europe, there's only one small plant in Belgium currently, and in North America, there are no plants at this time. And that is problematic given the recent reform to the EV tax credit in the US in particular, that requires 40% of battery raw materials by 2024 to be sourced from the US or a country with whom the US has a free trade agreement. So in terms of the benefits of the LCA that we see as a company, how are we actually using those results at this point in time? Well, I think with battery makers and OEMs committing to net zero, as shown in previous slides, they are looking to their supply chains to help them with those commitments, and we are part of that. So effectively, we are part of the battery makers and OEMs Scope 3 emissions. And we believe that, I think I've already said we're ahead of the curve here with the work that we've done to actually prove the environmental credentials of our products. Through doing the LCAs, we now have that hard data. So we can say that we have a very responsibly produced low carbon and fully traceable high purity manganese product. And what's been very interesting for us is it's one thing to say that that's attractive to prospective customers, but we recently signed an offtake term sheet with Verkor, who's a French low carbon battery maker to Renault. And in that, we've realized a price premium over the incumbent Chinese supply, partially driven by the superior environmental credentials of our products. So in fact, the price mechanism that's outlined in that term sheet is directly tied to our environmental performance, such that if we exceed our baseline outlined in the LCA, we receive a price premium, and conversely, if we fail to meet that baseline, then we would receive a price discount. So I think what's very interesting about that is it really incentivizes continuous improvement amongst suppliers to the battery makers and to OEMs. I think I will, in the interest of time, I'm going to leave it there for now to allow time for questions for the panelists.
Thank you so much, Louise, and thank you, all of our speakers. It's super interesting to see not only getting an update on the regulations, but also seeing how this is applied in practice and hearing from you how you have seen direct impact as well. We have a few questions. I will have a look here and see. So we have a question. What are the factors that contributed to the climate change impact of battery materials? I think I will direct that to you, Rob, to answer first.
Yeah, good question. So there really is a number of factors that can contribute to the climate change impact of a battery material. If you think about from the journey that the material has to go from ore into the ground to that high purity chemical or metal, a lot of the impact actually comes in that the latter stages of that refining, to really get it into that high purity, very specific composition. So, typically, if you're looking at might be a nickel refinery, or if you're looking at the graphite value chain, it might be during, say, the graphitization process. But there tends to be some energy intensive stages in those final stages of purification. And if those energy intensive stages are in locations with high grid intensity, CO2 intensity grid mixes, then that's usually a big hotspot that has an opportunity to be reduced.
Thank you. We also have another question, unless I have the other speakers interested in adding any comment to that. We have a question, I think that's probably more directed at Louise. What are some of the main challenges you encountered during the LCA? It's quite comprehensive. So how was that process? What were the main challenges?
Thanks, Camilla. Yeah, no, that's a really great question. I think the manganese space is much smaller than like lithium and nickel, and even probably slightly less advanced than cobalt, given some of the challenges cobalt's had around its environmental credentials. And as a result of that, and the fact that the majority of the industry is currently China-based, it was very challenging for us to get comparable data when we actually did the comparative LCA versus just measuring our own impacts. So what we did was we kind of worked with the International Manganese Institute, of which we are a member, on this. And I think also in turn, in having gone through that, there's now a great data set for any others within the manganese space that would be interested in doing a similar type of project. I think as we move forward as an industry, it's important to share those learnings in that spirit of continuous improvement. And, I think you've seen that a lot with a lot of these different battery metals institutes also look and undertake their own LCA for that particular battery metal. So I know, for example, that I think the Nickel Institute and the Cobalt Institute have done LCAs on, I think, the entirety of those particular battery metals amongst the producers or the developers who have measured that impact. I don't know if Robert's able to speak to that a little bit more, but not to put you on the spot, Robert.
Sorry, could you repeat that? Sorry, one more time, just that last bit.
Oh, it was more just around saying that the Nickel Institute and the Cobalt Institute, I think, have undertaken their own LCAs. So it's not just about the company themselves measuring their own impacts, but having an idea of the kind of carbon footprint of producing those battery metals as a whole at this point.
Yeah, absolutely. I mean, it's important to have both industry average data points to sort of have a guide for how we're doing as a society, because you kind of want to see that overall industry impact value for, say, manganese or nickel to be going down. But also it's very important to have that company specific, project specific, asset specific data. So those downstream consumers of your materials can spend more money if they want to get a lower impact material. So I think it's important to have both. Yeah.
And I think, Louise, you mentioned briefly here talking about the data, and we have a few questions actually asking into that more in detail. So there's a very specific question here on the production data from China, is that the updated latest from a trusted source?
As far as I'm aware, yes. I mean, as I said, it is challenging to get current data, but we have, as much as possible, tried to corroborate that with what we understand. I mean, we work with some industry experts that are very specific in understanding the current manganese players and market, and we'll have leveraged that as well. But like any data set, there is always going to be some inconsistencies. So I wouldn't want to say that it is exactly 100% up to date as of currently, but we worked off what we felt was appropriate, and we do stand behind the work that we've done.
I don't know if you were gonna add something, Rob. I saw you unmuting yourself there.
Yeah, no problem. No, just to say that it's constantly with when we're doing comparative assertions and we're trying to get the best quality industry data, it's always a snapshot in time, as Louise mentioned. But again, you know, we're always, you know, when you look at even background life cycle assessment databases, they're updated annually, and you know that's why, you know, the manganese impact data from today might be different from 2 years down the line, might be very different from 10 years down the line.
Thank you. And I think another very interesting question that's more on the practical side of things, I think directed more for you, Rob. But it's a question of what challenges does Minviro experience when undertaking LCAs for an operating mine versus an end user like Tesla?
It's a good question. They're very different challenges. So at the end of the day, you're trying to do the same thing. You're trying to get good representative data, and for an operating mine, you tend to, you've got an avalanche of data coming from maybe lots of different sources. At mining operations, they tend to collect data in different departments in different ways, you know, whether that's through, you know, the financial ERP system type data or measured data on site. It's really a lot of work in compiling that and organizing that and making sure it's consistent and verified. When we're working with the downstream, it's a little bit different because we're trying to navigate a little bit of opacity in the supply chain in terms of understanding who is your supplier once you go past tier 1 and tier 2. So you have to be sort of working with that supply chain, and a lot of talking, a lot of questions, and connecting up those supply chains.
Thank you. And we have another question here. I think that is probably more directed to you, Louise. Would you recommend other companies in your industry to do LCAs based on your experience? I guess from this question, also looking at what are the benefits that you've seen coming out of this?
Yeah, no, I would definitely recommend that raw material suppliers to the industry take a look at this. You know, I talked a little bit more or a little bit earlier about that kind of what gets measured gets managed. And it really does provide that baseline for companies to understand where they're at today versus where they could be versus where they're at against their peers. And to take decisions, whether, as Robert said, to design their projects in a slightly different way, perhaps, or indeed ways in which that they could, at a later point in time, also make changes to either processes or with their own suppliers, as I mentioned, that kind of scope 3, like reagents, etc. To then in turn further reduce their environmental impacts. I mean, obviously there's costs associated with all of that. And, you know, at the end of the day, you do have to sell a product that is economic. But as I mentioned earlier too, you know, we are seeing that price premium for a higher or a superior ESG related product. Does that answer your question, Camilla, or do you want me to talk a little bit more to any other benefits.
I hope so. I think so. Otherwise, we'll ask the audience to raise their hand if or ask another question to get it more in depth. There's a very specific question here. I think in terms of the data, again, that goes back to when you mentioned the Chinese companies. It says, have you already considered that Chinese companies use green electricity to plan and increase green electricity in the future? Or is it only Chinese grid mix considered for the comparison? So I think that question goes back to the data and the comparison.
Yeah, maybe I can answer that. So we try and be as, again, reflect reality as closely as possible. So if we understand there's specific data for specific plants, then we will use that specific data. We very rarely, in these types of comparative assertions, we wouldn't just use a generic Chinese grid mix. We would be specific to the region, and if it's more, hydro dominant, renewable dominant, then that will bring down their intensity. So it's a more, it's a representative, fair comparison.
Thank you. And I think I see Luis nodding, so I think that would cover it on your end as well. And I can see there are some questions in terms of getting in touch with our speakers to have further conversations and explore opportunities. We'll be, I'll be in touch with you afterwards, and we'll send out contact details so you can reach out. We have another question. How can we make it possible to have a single definition and interpretation for responsible sourcing across actors? That's a very good question. I think that's probably something that we hear quite a lot within this area. I don't know who of you will give that a go first.
I can take a stab at it. I mean, I think it's a very good question. And I think if you look at the broader mining industry, you have seen a lot of industry associations produce benchmarked or frameworks whereby members of those industry associations have to report against certain kind of ESG metrics. So an example I would give would be, say, the Mining Association of Canada's Towards Sustainable Mining Initiative. I was previously in the gold mining industry, so I know the World Gold Council had a very comprehensive responsible gold mining principles. And in that, it was a very structured framework to report against different ESG metrics. And I think the same type of approach is starting within the battery metals industry. But I think, the space is niche and it's nascent. And so I think you're going to see increasingly more of that, specifically amongst industry associations like the Nickel Institute, Manganese Institute, et cetera, on a go-forward basis. As I mentioned before, it's just simply the right thing to do, but these things take time. And equally, they've also got to be developed in a manner that is workable for members and for raw material suppliers, because you don't want to just measure absolutely everything. You want to be measuring things that count for you and that count for your stakeholder groups. And they also have to be in line with regulation. And as Megan spoke about earlier, regulation is moving so quickly that you're almost probably going to be paralleling those processes. So yeah, a couple things to keep in mind there as we move towards that.
I'll just add to that. Thanks, Louise. I think that was very solid response for all the challenges that companies throughout the battery value chain are facing and asking themselves. And I think it's it's something that that has been around for a while. There's a proliferation of standards, of regulation, of various definitions of responsible sourcing. On top of that, the interpretations by auditors are also different. So the number of challenges that we face as an industry in terms of aligning on a single definition are quite large. There are efforts by regulators to take the role of standardizing definitions and approaches. This is largely seen within the EU. Of course, this is, this needs to be done very carefully, and there have been, efforts that have more or less failed so far in this regard to either use frameworks that enable companies to align with existing industry schemes or frameworks under the EU conflict minerals regulation. This was attempted. However, years down the road, the implementing agencies still have not approved frameworks that can be used for companies to demonstrate compliance. So I think that we just need to keep ensuring that everybody here contributes to the conversation, and that we work toward a common understanding amongst all actors, and aligning on common methodologies for calculating things like carbon emissions is, we'll learn a lot from experiences like that through the EU battery regulation.
If I can just actually add to that too, I mean, I think we're a member of the Global Battery Alliance that's, developing the battery passport. And I know that they have actually issued kind of 2 frameworks amongst a number of others that they're also developing, one being the kind of GHG framework and the other being the human rights one. And that does, I think, get us pretty far along the path of some standardization of reporting, against kind of responsible sourcing practices.
Yeah, agreed. And I think that's actually a good point. I mean, if anyone's super interested, that's a separate conversation about battery passport, but I will just mention, because we did have a webinar on that specific topic a couple of weeks back, fully covering the battery passport, and with speakers from Yumiko and Elbamali going through that whole thing. So it's a spiraling conversation that can be covered separately. We do have one final question. I think we are also close to running out. It's in relation to regulations further, now that we're on the topic. Just where do you see regulations evolving in relation to LCAs going forward?
Yeah, I think, there's definitely a trajectory of just increasing requirements for life cycle assessment thinking or life cycle assessment data in regulations. So it's a bit of a milestone for the European regulations on carbon footprinting for batteries. That's kind of like the most ambitious and leading sort of life cycle assessment sort of regulation. But I think the trajectory is only going one way. There's been sort of suggestions that batteries is the first sector, but it's going to go into some other low carbon transition technology sectors like photovoltaics and other sectors. And then that will obviously percolate right through the supply chain. So the requirement to have life cycle assessment data at each asset level within these different supply chains. I think it's really powerful as well. I mean, we're also not just looking at these low carbon technologies, but looking at, say, a big thing that we're relying on to meet our climate goals, which is negative carbon. I think there's life cycle assessment, which is actually identified in the Inflation Reduction Act for those companies that are getting investment for negative carbon emissions. So we're starting to see it as a method to prove technologies as well. So yeah, definitely going in the same direction.
Thank you so much. Any final comments from our speakers? Otherwise, I'll say thank you so much